In this situation, we're going to look at what Le Chatelier's principle predicts if we change the pressure or volume of a system. Now, there's one thing to remember about pressure and volume. Increasing the pressure of a system is essentially the same as, or saying the same thing as, decreasing the volume. So pressure and volume are inversely related, and in some problems you can say increasing the pressure, but you could think about it as just decreasing the volume, and it'll work just the same way. Le Chatelier's principle predicts that if you reduce the volume of a system, this will cause the system to shift in the direction with the fewest moles of gas. Now, this is important to remember that we're only thinking about moles of gas in this equation. So in this equilibrium, we have all of the components that are in the gas phase. On the reactant side, we have 2 moles of NO gas and 1 mole of oxygen gas. So we could just write a note to ourselves that on the reactant side, we have 3 moles of gas. On the product side, we only have 2 moles of NO2 gas, so there are 2 moles of gas in this situation. So now, if we take, for example, let's say we reduce the volume. Going back to our Club EQ nightclub analogy, if you have a smaller dance floor, what's that going to mean? It means that some of the patrons are going to have to leave the nightclub. So it works the same way. If you reduce the volume, you're going to have less room. And so if you decrease the volume, you're going to shift in the direction with the fewer moles. So for this particular equilibrium system, if we decrease the volume, in this case, this equilibrium will shift in the direction with the fewest moles, which means in this particular equilibrium, it will shift to the product side, it will shift to the right. And the opposite is also true. If we were to increase the volume, you'd have more room on the dance floor, so more people could enter the nightclub. And so the reaction would shift to the side which has more moles of gas. So if you increase the volume, the equilibrium will shift to the side with the larger number of moles of gas. In this example, that is the reactant side.